Now, dear students, we are continuing the first year limits. Now here our heading is method of evaluation of algebraic limits at infinity. So when you are seeing x tends to infinity or minus infinity, how to evaluate the limits, that we are going to discuss now. So the first question is 5x minus 6 by root over 4x square plus 9. So this solution, so this given limit is equal to, okay, this problem 5x minus 6 by, so again here only let us continue now, solution. So this limit is equal to, now take x common from numerator, then you get 5 minus 6 by x, right? So now please take x square common under the square root sign, then it would be 4 plus 9 by x square as the limit extends to infinity. So this is equal to x into 5 minus 6 by x divided by root x square is mod x, root x square, since root x square is mod x. So root x square is mod x into root over 4 plus 9 by x square as limit extends to infinity. So here x tends to infinity means x greater than 0 here. So when x greater than 0, mod x will be equal to x. As x tends to positive infinity means x is greater than 0. X is greater than 0 means mod x is equal to x. So then in the next step, x into 5 minus 6 by x by mod x is x, x into root over 4 plus 9 by x square as limit extends to infinity. Now this x and x get cancelled, then you are left with, after cancelling x and x, you are left with 5 minus 6 by x divided by root over 4 plus 9 by x square as limit extends to infinity. So as x tends to infinity, we have 1 by x tends to 0, and as well 1 by x square tends to 0, 1 by x cube tends to 0, etc. So as x tends to infinity, we have 1 by x tends to 0, 1 by x square tends to 0, 1 by x cube tends to 0, etc. So this is 5 minus that 1 by x tends to 0, so 6 into 0, 0 by root over 4 plus that 1 by x square tends to 0, so 9 into 0, 0. So this is equal to 5 by root 4, which is equal to 5 by root 4 is 2. So this is 5 by 2. So the final answer is 5 by 2. Understood? So now let us go for next question. Next question is root over 3x square minus 1 plus root over 2x square minus 1 divided by 4x plus 3 as limit extends to infinity. So this limit we have to evaluate. So see solution, this given limit is equal to, this given limit is equal to, so under the square root sign you take x square common, then outside it would be mod x and inside it would be 3 minus 1 by x square. Similarly here mod x to root over 2 minus 1 by x square. divided by, here take x common, 4 plus 3 by x as limit x tends to infinity. As x tends to infinity, mod x is equal to x, we have discussed in the previous case. So this is x, this is x. So take x common overall, then you will have root over 3 minus 1 by x square plus root over 2 minus 1 by x square divided by 4 plus 3 by x into x. Since x tends to infinity implies x greater than 0 implies mod x is equal to x. So as limit x tends to infinity, now this x and x get cancelled. So now this is root over 3 minus 1 by x square plus root over 2 minus 1 by x square divided by 4 plus 3 by x as limit x tends to infinity. So as discussed in the previous context, as limit x tends to infinity, 1 by x square tends to 0 and 1 by x tends to 0. So this results as root 3 plus root 2 by 4 plus 0, which is 4. So that final answer is root 3 plus root 2 by 4. Have you understood? So now let us take another problem. Now this time we'll take with minus infinity, because we have solved two problems with plus infinity. So the question is root over x square minus x plus 1 plus x limit x tends to minus infinity. Evaluate. So in this evaluation, first you have to take x as minus y. Let x is equal minus y. Therefore, as x tends to minus infinity, okay, so y tends to infinity. It is very clear. When x is equal minus y and as x is tending to minus infinity, so naturally y tends to plus infinity. So now if you take that given problem, so limit x tends to minus infinity, root over x square minus x plus 1 plus x, if you take, now if you go for change of variable, then wherever x is there you have to put minus y. So root over minus y the whole square minus of minus y plus 1 plus of minus y as limit y tends to positive infinity here. So this is equal to root over, this is y square plus y plus 1 minus y as limit y tends to infinity. Now here you have to rationalize the numerator. So if you go for rationalization of numerator, so you get directly, I am writing, if you rationalize the numerator, then it goes to a minus b into a plus b, a square minus b square. So y square plus y plus 1. A square means y square plus y plus 1, a square minus b square means y square. So divided by root over, I am rationalizing numerator, very simple. So here you get plus y. So on rationalizing numerator, that is the concept you have to write. So a minus b into a plus b, a square minus b square, which goes here by 1 into this as limit y tends to infinity. Now this plus y square minus y square get cancelled. So y plus 1 by, now you take y square common, so outside it is mod y, so inside it is 1 plus y by y square, which is 1 by y plus 1 by y square. Okay, you keep y here as it is, limit y tends to infinity. So as y tends to infinity, y is greater than 0, so mod y will become y. So in the numerator, if you take y common, it is 1 plus 1 by y, and in the denominator you take y common, then you get 1 plus root over 1 plus 1 by y plus 1 by y square as limit y tends to infinity. Are you following? Now this y and y get cancelled, and as we know that as y tends to infinity, 1 by y square all goes to 0. So this is 1 plus 0 by 1 plus root 1, which is equal to 1 by 1 plus 1, which is 1 by 2. So this limit is 1 by 2. Like this, you can go ahead. So if you go to another interesting problem, one plus 2 plus 3 plus, evaluate the limit 1 plus 2 plus 3 plus 4 plus so on plus n by n square as limit n tends to infinity. So we know, we have learned in early classes, 1 plus 2 plus 3 plus so on plus n, sum of first n natural numbers, is equal to n into n plus 1 by 2. So this is equal to n into n plus 1 by 2n square. Limit, and here there is n square, no, that's why I wrote 2n square. Limit n tends to infinity. Now if you go for cancellation, n plus 1 by n, limit n tends to infinity. That 1 by 2 constant you can write outside. So 1 by 2 constant I have taken outside, and there is, after cancelling, n will be there in the denominator. So n plus 1 by n, this is equal to 1 by 2 into, so this is if you split 1 by n, limit n tends to infinity. So I'm splitting, plus n by n, limit n tends to infinity. I'm splitting the fraction. So this is equal to 1 by 2 into, this goes to 0, and this is 1. So this is equal to 1 by 2 into 1, which is 1 by 2. So this is an interesting problem. Okay. Another interesting question is, x plus 1 whole power, x plus 1 raised to the power 10, x plus 2 raised to the power of 10, and so on, x plus 100 raised to the power 10, divided by x power 10 plus 10 power 10. As limit x tends to infinity. This is our next question. So dear students, you see, so this is equal to, if you take x common inside, then you get x power 10 into 1 plus 1 by x whole power 10. So similarly everywhere you get like this only, so take x power 10 common, then you get here 1 plus 2 by x whole power 10, and here so on, here plus 1 plus 100 by x whole to the power of 10 divided by, so x power 10 here also if you take common, 1 plus 10 by x whole power 10 as limit x tends to infinity. So this x power 10 get cancelled. Now 1 by x, 2 by x all will become 0. So this is 1 plus 1 plus 1 plus so on over, this is 1 plus 1. sorry 1 plus 0. So as x tends to infinity, 1 by x tends to 0. So this is 0. Now how many ones you are adding? You are adding 100 ones. So this is our 100 additions. So 100 additions of 1 gives, and this is 100 additions of 1. 100 additions of 1 gives you the answer 100. 100 by 1 is equal to 100. So that limit is 100. Understood?